Okay, we are on the last page, and like the past few pages, I've pre-done some stuff just to make it less tiresome to go through. So we've got a funnel, number 26, a funnel in the shape of a cone. It drains through a hole in the bottom at a rate of 25 milliliters per second. The units that they give us are R is 5 and H is 20. This question doesn't make any sense unless we assume that these are in centimeters, so I've written them out here in centimeters. How long will a funnel filled with liquid soap, and I'm guessing this is the rate to drain for soap, I don't know, take to empty to the nearest second? So we know the volume of a cone. So it says if it's filled with soap, that means it's full all the way to the top of soap. So what's the whole volume? How many milliliters of soap? The volume of a cone is 1/3 pi r squared h. We know pi, we know r, we know h. Easy, right? Just plug them in. We get 523.598 blah, 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 blah centimeters cubed. They tell us over here that 1 centimeter cubed is equal to 1 milliliter. So that's a 1-to-1 conversion. You could write out 523.598 centimeters cubed times 1-to-1, 1 centimeter cubed over 1 milliliter, and cancel, and you get the same number. But I will definitely forgive you if you don't, because I wouldn't bother. Once we've got our volume in milliliters, they tell us it drains at 25 milliliters per second. We take our milliliters here, and we want a time, so we have to just have seconds. We have to be able to cancel out milliliters. So I'm going to multiply by a unit fraction that's got milliliters on the bottom and replaces it with seconds. I know that 25 milliliters per second is 25 milliliters for every 1 second. So I take my 523.598, multiply by 1, divide by 25. The only unit remaining is seconds, and I get 20.944, which to the nearest second is 21 seconds. We're just going to assume the soap isn't all stuck to the sides and like slowly dripping out over the next few hours. We're going to assume this number is right, which seems like a pretty big assumption to me, but hey. Number 27, our last question here. We have a cone with a base diameter, so the diameter is 8 inches, and a volume of 259 cubic inches. They want the slant height, which is along this line here. If you were to lay a ruler or a tape measure along the edge, that would be the slant height. So to get the slant height, we need to do a little bit more work. They tell us diameter of the cone and volume, and they want slant height. The formula for volume is 1/3 pi r squared h. So we don't know, well, we know a third, yeah, we know pi, yeah. We don't know any of these guys. But we can get r pretty easy, right? So if we know diameter is 8, radius is always half a diameter. So if we take 8 inches and divide by 2, we get 4. So we know radius, that's okay. So now we only have one real unknown. Our major unknown here is just h. We're looking for h. To isolate for h is okay. It's not too tricky. We just have to undo everything on the same side as it, right? So we want to throw everything over to the side with the v on it and away from the side with our unknown. When we throw them over, if they were being multiplied, they become divided. If they were being divided, they become multiplied. So we get 3 on the top now, v's, and pi r squared now moves down to the bottom. So we have 3v over pi r squared is equal to h. We know v, we know r, we know pi, we know 3. We can plug them in. And we get 15.5-ish, 15.45, and some other numbers, inches for our height. That is the height of the cone. That is this height. That is the line that drops down to the bottom, center of the cone to the peak. But that's not what we want. We want the slant height of the cone. We want that pink line. So if we rotate that cone so that we can't see it's not tilted towards us at all, we're looking with our eye flat on the table, it looks like, well, any cone looks like an isosceles triangle. So if we draw out the cone, so the whole cone is here, if we draw out that cone, we know that we have the height of the cone, and we know we have the radius along the bottom, and those two we know have to be at 90 degrees, they have to be perpendicular. So we can find the hypotenuse, or the slant height, very easily because of our old buddy who never writes this anymore, Pythagoras. But he told us in one of his old letters that a squared plus b squared in this situation would be c squared. So 4 squared and 15.46 squared, we're looking for just c, not c squared, so we have to remember to take the root. And the root of the sum of these here, which is 254.95 square inches, will be c. The root of that is 15.96, so to the nearest inch, 15.96 rounds up to 16 inches. So this line here, this slant height here, is 16 inches. And that is the end of your Unit 2 assignment, which just leaves you the Unit 2 test. And so if you haven't done the quiz yet. But Unit 2 test, which is coming up soon.